For those of you that don't know me, I'm Chris. I have a background, like Seth mentioned, in hardware engineering, and I did a brief stint in PCBA manufacturing. And now I run Common Ground Electronics, where I get to play with embedded systems and do cool projects for people. So I want to start with this quote. Some of you might be familiar with it. It's called Gall's Law, and it says, "A complex system that works is invariably found to have evolved from a simple system that worked." And PLM can be a very complex system. I think a lot of people are familiar with it in kind of the enterprise environment. And so this talk is about trying to create a simple system that works with KiCad to set up a PLM workflow with the goal of being able to build open source designs. And so that has kind of a little bit of a unique set of constraints that I think a lot of people approaching PLM don't really typically come at this problem from. Goals. So I want to give you enough that you can get started with PLM in a weekend. And I also want to walk through a KiCad integration with a PLM tool called Aligni. And so we've only got 40 minutes. This is going to be a little bit of a quick kind of scratch the surface introduction to PLM. There's really no way to do like an exhaustive covering of all of the different aspects of PLM systems or cover multiple PLM systems, but I just want to give you enough to kind of get a sense of what these systems are and how you might be able to get started using them with KiCad. Okay, so what is a PLM? PLM, Product Lifecycle Management, it's a process that combines best practices and software tools to centralize and structure product information over the course of the product development lifecycle. So that sounds kind of like a mouthful, but we'll kind of get into what that means. Every product that gets manufactured has a life cycle, and so it usually starts from defining the product requirements, going through a series of validation and testing phases, and then ultimately ramping up to mass production and going to eventually through service and end of life. And as you go through that life cycle, there's kind of this multiple cycles of this design, build, test, and learn cycle where you're iterating on this product over time. And each of those iterations have a lot of data that gets generated along with each of those iterations of that piece of hardware. There's part numbers that get generated, revisions, different parameters and specifications that are associated with each revision. You generate CAD files and drawings. You have a bill of materials that tells you what components go into that piece of hardware. And then you've got to manage suppliers, vendors, distributors. There's regulatory compliance aspects to that. So it's a lot of stuff that you kind of have to manage. And I think for most people, especially folks that are using KiCad, a lot of times this stuff gets stored in KiCad, or in spreadsheets and Google Drive and random folders on your laptop and emails. And so there's like all of this kind of mix of places where this data is stored. And none of these places are really like the ideal location for this data. There's a couple reasons why it's not ideal. One is that product data is siloed. So, for example, if you put manufacturer part numbers or vendors in KiCad, it's not super easy for another system to access that data. I mean, you can parse the files and pull it out, but it's not like there's an API where you can just grab the data that you need. And then that product data can also become outdated over time. So there's, manufacturers get acquired. If you put in Fairchild in your bill of materials today, and then you come back to those files later, you may find that they've been acquired by ON Semiconductor, or other things change about that manufacturing and supply chain data over time. And the last thing is that it's much easier to make mistakes with manual input. So you can see here, this was a design that I worked on a while ago. There was a copy and paste error between the value field and the NPN field, and we built the boards with SPI version of a chip instead of the I2C version, and nothing worked. So it's really easy to kind of make these small errors if you're storing data in KiCad and copying and pasting from one design to the next design to the next design. And that kind of brings me to kind of a more like philosophical slide about kind of what we should be kind of striving for here, which is that I think ideally your CAD design should really represent your design intent and not a snapshot of the current kind of supply chain data that we have today, which could change, very easily tomorrow. So you can see there's like, in KiCad, you want to be able to say this design uses a 10K ohm resistor, plus or minus 5% tolerance, yada, yada. And then when you actually go to build that board, you want to be able to say that that part is actually going to be built with a Yago resistor with this part number, and we're going to purchase it from DigiKey or another distributor. So there's got to be a better way to do this, right? And people realize that, so they built PLM software. And there's a lot of options that you can pick from today. There's all sorts of different companies. Most of these are typically geared more towards enterprise deployments, but there's also tools for small and medium businesses and things that even makers and hobbyists can use. And so I will go over an example of one of those tools. So what does a PLM software do? PLM software is intended to be the single source of truth for product data. So it's a place where all of your part numbers are stored. It manages your revisions, your bill of materials. It has document control. One of the other things that it does is it enables teams to access that product data. So you may have a team composed of engineers and designers, product managers. Each of those different teams are looking to access information about the products that you're building. And then you can even have access for external vendors like your contract manufacturer, where you may want to be able to say, here's specific access to a design that your fab house or your contract manufacturer building your boards is going to have access to. There's also change management workflows, change history. So you've got kind of this audit trail for changes that are happening in the system. And then it also integrates with other tools. So PDM, MRP, MES, PIM. If you're sitting there thinking, what the heck is this guy talking about? I'm going to get into that. So there's a lot of these kind of three-letter acronyms that when you first approach this are very kind of a little bit overwhelming. And so we'll talk about what these things are. So deciphering the alphabet soup. To give a very, very quick and short explanation of what some of these things are, product data management is an engineering tool, and it's designed to help, product data management, PDM, is an engineering tool that was kind of originally designed to manage and version design files and specifically mechanical CAD data. And then you've got PLM, which is kind of a superset of that, intended to be a central hub for product data, approvals, lifecycle management. Then you've got material requirements planning, which is kind of more on the manufacturing side. That's got inventory management, purchasing, scheduling, and like demand planning tools. And then you've got kind of the big 900-pound gorilla, which is enterprise resource planning, or ERP. You probably have heard that term. And that's a tool that's kind of a superset of MRP designed for kind of managing your business and supply chain logic. So that has tools for finance and HR and kind of running your entire business. So if we look at kind of how those things are kind of related to each other, PDM is typically a subset of PLM. PLM kind of grew out of PDM over time. And then MRP is typically either a standalone module or a module inside of a larger ERP system. More recently, on the ECAD side of things, Git has started to take over some of the functionality that a PDM would provide. So things like version control of design files, some of that's kind of moving out of the PDMs, and you see people using Git and GitHub and GitLab for some of that functionality. And then finally, the integration of these tools. Oftentimes you'll have product data flowing from your PLM system to the MRP or the ERP system. So when you go to actually manufacture a product, your part numbers and manufacturing bill of materials, that will get transferred from the source of truth in the PLM tool down to the ERP or the MRP system. Okay, so let's get into the kind of the meat of this talk here. So this is really about integrating KiCad with a specific PLM tool, a tool called Aligni. And so I kind of want to start with like the end goal, which is what this is going to look like once we kind of walk through all the little pieces that you need to put in place to get this working. So the first thing is that we want to have all of our part data, all the product lifecycle data stored within Aligni. So not having any unnecessary data stored in KiCad. The result of that will be that we get an automatically generated library of fully defined parts. And sometimes, historically, those have been called atomic parts in KiCad. What it means in the context of this talk is really that the parts have a footprint defined, a data sheet, a description, and an internal part number. And so that'll give us all of the information that we need to link those parts back to the kind of source of truth part data that is stored in the PLM tool. Okay, the kind of second piece of this is that we also want to be able to drive the creation of assembly BOMs in the PLM tool from the schematic. So use the schematic as the source of truth for the parts that are going onto the BOMs for like a printed circuit board assembly. Okay, so let's do a quick introduction to Aligni. I'm not affiliated with Aligni, but I just happened to kind of find this tool and found it to be really useful and capable of being integrated with KiCad. So that's what I ended up picking for this talk, but I'm hoping that some of the concepts that we go over here can be used with other PLM tools, or you can even use Aligni with other CAD tools as well. Okay, so Aligni is a combination of a PLM and an MRP. So it has functionality of both, and it's kind of tightly integrated together so that you can use both the kind of PLM and MRP aspects of the tool kind of seamlessly within one user interface. It provides a part database, which they call the item master. It also has engineering change management workflows, quality workflows, and then on the MRP side of things, it has inventory management, planning, build management for managing builds of assemblies. It has supply chain tools, so you can do all of your purchasing and quoting through Aligni. And then it will let you also manage manufacturers and vendors, and it even has some kind of customer management stuff in there as well. So this talk is kind of solely about the very first piece of this, which is the part database. This is kind of the core piece that makes everything else in the list work. And it's basically the part numbers, the part data that drives all of the other kind of parts of the workflow. And I think this is the piece that most people in this room are kind of looking for as a starting point. Even if you're, a single contractor, you may not need change management workflows or quality tools or a lot of the other stuff, but you might just be looking for a way to manage part numbers and bill of materials. And the part database piece in Aligni will give you that. Quick note on why Aligni, because there's obviously kind of a lot of options that we can pick from here. I was looking for a solution that was hosted. I didn't want to have to do IT stuff and host something myself. And I wanted something that was simple, that didn't require any custom development or a lot of like configuration to get the system up and running. I wanted something that was kind of had out-of-the-box support for KiCad database libraries or HTTP libraries. I also wanted something that was ECAD agnostic, so something that could be used with, KiCad today, but also Altium tomorrow, that wasn't going to be tied to a specific CAD tool. Something that I could play around with for a while, that had a free tier, that wasn't something that I had to kind of pay for initially, and was looking for something that had public access for open source projects. So I wanted to be able to publish a schematic on GitHub or on my website for somebody to download, and then have that schematic reference parts in this PLM tool, and not have that be a closed kind of ecosystem where you had to sign up for an account or log in or be part of an organization to actually access the rich part data that was stored in that tool. And then I also wanted automatically managed part numbers. And the only thing that I found that kind of really met all of those criteria at the time was Aligni. But there's also some work being done in PartsBox to try and get some of this stuff kind of built out. They just recently released support for HTTP libraries. So there's other things that I think are worth looking at now, especially as things change over the next year or so. Okay, so this is going to kind of move more into like a tutorial kind of description of how to actually get this set up. So hopefully you'll be able to kind of follow along. I'll publish these slides on my website. The link will be at the end of the talk. But you should be able to kind of follow along this and be able to get things set up yourself. So the first step here, Aligni has a page where they have all of the kind of public organizations. They have private and public organizations, depending on whether you're on a paid plan or if you've got the free public account. And so if you go to this URL, you can sign up for an account, create a new organization, and then it'll ask you if you want to do a public or private organization. I would say you could start with the public just because it's free and it's kind of a good place to get started playing around with the tool. Okay, so the first thing that you see when you log in is the Aligni dashboard. Like I mentioned before, the focus of this talk is on setting up the item master. That's the kind of main parts database where you're going to store all of the data that we're going to be using for the KiCad library integration, and it'll be kind of your source of truth for part data moving forward. Single source of truth. It's a central repository that you can use not only in this system, but also in other systems. And it's backed by a relational database. So you get nice, like real rich relationships between the data and the tool. So if a part is referencing a manufacturer and that manufacturer name changes or the website changes over time, you'll have links that will be updated within the tool, and you're never going to have stale copies of data kind of lying around in your parts. Okay, so this is what a part looks like in Aligni. At the top here, you can see parts have a part number. They have a part type. There's a manufacturer, and this is a link to an actual manufacturer record in the system. And then there's a manufacturer part number and all the typical kind of additional fields and data that you would expect from a part. You can have custom fields. So the fields in bold are the ones that come built in with Aligni, and then you can also add your own additional custom fields or custom part parameters for additional information that you want to store on a part. There's alternate part numbers. So these are other parts in the system that can be substituted for this part in certain scenarios. And then the last piece of this here is the where used section that will show you a list of assemblies that assemblies where this part is used. So if you're using this resistor on other boards or other assemblies that are getting built, you'll have a list of all the places in the system where this part is used. Parts have revisions. These will let you track changes to parts over time, and we'll talk a little bit more about this later. Because Aligni also has a MRP functionality, if you're looking at a part, you can also see information about the inventory of that part. So which warehouses have stock of that part will be listed in the tool. You can see in this case, we've got 1,000 of these resistors sitting in the JLC PCB warehouse. And there's also supply chain data about this part. So this is where you would actually set up the relationships between this specific manufacturer and part number and a series of distributors where you would actually buy this part. So here you can see we've got a relationship that says this part's available from DigiKey in different types of packaging formats, cut tape, tape and reel. You can also get it from Mouser and Newark, and also from LCSC. So there's a one-to-many relationship between a part in the system and the places where you can actually buy that part, and you can set up a lot of these different relationships in an easy way, whereas if you were trying to kind of shove this data into the KiCad fields, it's just much more kind of a manual process, and it's a lot harder to manage those records over time. Okay, so you obviously want to build out a big library of parts. How do you actually get a part into Aligni? Well, there's a couple things you got to set up initially before you can create a new part, and we'll walk through some of those right now. The first thing is a part numbering scheme. So Aligni will automatically generate part numbers for you if you set it up to do that. And there's a lot of ways to do this wrong, where you can kind of end up in situations where, for example, with intelligent part numbering schemes, you end up with parts that kind of don't really fit in one specific category or another. So my recommendation would be, if you don't have specific requirements and you're just looking for a place to start with a non-intelligent part number scheme, just a series of numbers. Let Aligni generate those for you, and pick something around 6 to 7 characters long. That's kind of where the human mind can keep all those characters in your head, and start it with a 1, because if you start with 0, Excel is going to truncate those part numbers when you stick it into a spreadsheet. Okay, so part types. These are kind of like categories for parts. It's a way of organizing groups of parts in Aligni, and it also lets you set up behaviors and groups of parameters that are associated with specific parts in the system. So you can say, all chip resistors have power rating and tolerance, and all chip capacitors have a dielectric characteristic. So you can set those up in Aligni using part types, and then assign characteristics to those part types. And then the last thing here, and this is going to be important when we set up the part libraries in Aligni, or the part libraries in KiCad, is custom parameters. So KiCad's going to ask us for a symbol to associate with this part and a footprint to associate with this part. And this is how you would go in and set up a custom field. In this case, it's just a string that's called KiCad symbols, and it has a name and a description, and then a list of part types that are associated with that, so that you can say this field needs to show up on all of these different part types that we've set up in the system. Okay, so you've gone through, you've put 100 parts into Aligni, you're ready to go and place those into a KiCad schematic. How do you actually go about getting those parts that are in Aligni to show up in a library in KiCad so you can actually do something cool with them? So KiCad has this cool feature called database libraries. And the way that they work is it essentially takes data from a SQL database that has a bunch of records or kind of rows in the database that describe each part. And then each of those rows will reference an existing KiCad symbol and optionally an existing KiCad footprint to kind of merge all of that together into a part that gets placed into the schematic. And Eli talked about this in his talk. This is exactly the same kind of mechanism that was happening with the HTTP libraries. It's the same thing, just in this case, we're going to be using a SQL database to drive this instead of the HTTP libraries feature. There's a series of inputs that KiCad needs to actually make this work. And so we'll walk through each of these in detail so you kind of know where they're coming from. So the first thing that we're going to use is a SQLite database. And that actually comes from Aligni. They provide a tool called the Replicator. It's a Windows application that you can run that will essentially create a local SQLite database on your computer from your parts in Aligni. So every part that you have set up in Aligni will get downloaded and synchronized into a SQLite database in a location that you specify, and you can tell it to update that daily on a certain schedule, or you can also refresh it whenever you want manually as well. And the download link for that tool is right here. And if we look at the schema for that database, you can see there's a parts table, and then it has all of the fields and the custom parameters that we defined on the Aligni side. So anything that you had put in as a custom parameter will show up within this database. And then also, if we just look at the data in here, you can see that all the parts that we have defined in Aligni show up in this database with, here's the key piece, the part number associated with them. Okay, so I kind of glossed over, there's this ODBC driver thing. Eli mentioned this as well. It's essentially a abstraction layer so that KiCad doesn't have to know how to talk to every single type of database management system. It can just talk to this ODBC driver, and then the driver handles all the kind of messy details of interacting with different types of databases. So for SQLite, the one that we're going to be using here is this SQLite ODBC driver. You can just download it from this website and install it. And if you get everything set up correctly, you should see the driver installed in this ODBC data source administrator. I don't have a Linux machine that runs KiCad, so I couldn't show an example of that. But there's instructions at the end of the slides for Windows, Linux, and Mac OS. And the key thing to pay attention to is this driver name. We're going to use that when we get into the configuration file, because you've got to be able to point the configuration file to a name that matches that driver name. Okay, so the second piece we need is this database library configuration file. This is that KiCad_DBL. And this is a JSON file that tells KiCad how to actually map the fields in the SQLite database to fields on the symbols that it's going to generate in the KiCad schematic. So it's simple enough that I can actually just walk through the whole thing here real quick. This screenshot here is just showing kind of how I set up my KiCad library that uses this database libraries feature. So I have a folder called databases that has the SQLite database, and then a folder called symbols that has the KiCad configuration file. So I'll actually, since I'm running a little bit low on time, I'll skip walking through the individual details of the configuration file. This is all documented on the KiCad website. So all the individual details here you can look up in the KiCad documentation. But it's basically just this JSON file. It says look for this SQLite ODBC driver, and here's a link to the database file. And then you'll go through and set up which fields in the database map to specific fields on the symbols in KiCad. So skip through this here. One quick note, so I end up creating template libraries that I use for the symbols. So if you can imagine if you have 1,000 resistors, all of those resistors are going to use the same symbol when it actually creates the database libraries. And so these symbols have kind of placeholders for the fields that are going to get populated by the database libraries here. Let me skip ahead a little bit. One thing to note, when we generate the symbols, I showed that there was a link back to the part in Aligni, and the replicator database doesn't actually generate the database with that URL pre-populated. So one easy way to get that URL to show up is by adding a custom parameter in Aligni that has a link to that part. And then at the end of the slides that I'll publish, I'll show another method of doing that uses a SQL command to automatically generate that link instead of having to put it in as a custom parameter. Okay, so the last kind of piece of this puzzle is to add that KiCad database libraries configuration file into the symbol library table. This is just like you would add any other symbol library into the system, and this is what KiCad uses to generate that list of symbols when you actually go to place a part in the schematic. Okay, so now if you were to go up and hit the add symbol button in the schematic editor, KiCad would pull that information from the database, automatically generate this database library, and you can see here we get a list of parts that are with the part number associated with them. Those parts have a footprint defined, a data sheet link that links back to the part in the Aligni database, and it has a description and all the information we need to kind of connect that part in KiCad to the actual real source of truth in Aligni. The cool thing about this is that you can do parametric part search in Aligni. So you can say, show me all the resistors from Yago that are chip resistors that have a tolerance between 5 and 10%. And then you can search for those parts, get the part number you need, and then when you're in KiCad, you just go back into the search filter, punch that number in there, and it will filter the list to give you the exact part that you're looking for. You get nice links between KiCad and Aligni. So even in PDFs, you can click on a symbol in the PDF, and you get a link back to that part on the actual part page in Aligni. And then, how am I doing on time? 2 minutes, okay. So I'll wrap up with this here. Once you've got parts that are placed in the schematic, you obviously want to build something. You're probably building a circuit board. So in this case, we'll walk through an example of how to actually take the parts from the schematic and import those back into Aligni to create a bill of materials for that board that you can then use in Aligni to represent the BOM for that board. And you can then share that with an external vendor, like a contract manufacturer, who's actually going to go and build these boards. So this is just an example, kind of simple design, one that I can fit the whole bill of materials on a slide here. So you can kind of see there's your basic bill of materials export from KiCad. The main thing to note is that it has an IPN column, and all of those part numbers are the same part numbers for the parts in Aligni. So when you go to import that CSV file into one of the part assemblies in Aligni, there's this mapping process where you'll map the part number column from the CSV to the IPN column in the CSV file to the part number in Aligni, and it will automatically match up all of those parts, import them, and create that bill of materials in Aligni for you. So it's kind of this nice workflow of placing parts in the schematic based on the Aligni database, and then exporting the bill of materials out of KiCad and using that to create the assembly BOMs in Aligni. So I think that's a good place to kind of wrap up. There's some additional things here that I don't really have time to cover, talking about best practices for revisions. You can download the slides and check those out. And then a couple limitations that I just want to kind of mention before we wrap up here. So there's currently no way to place different schematic symbols for a single database part in KiCad. So one reason why you might want to do that is you have an M.2 connector. You want to be able to use that with SparkFun's micromod system or PCI Express M.2 specification. Those symbols have different pinouts, and there's currently no way to kind of pick which symbol you want while keeping the same part number and same footprint within KiCad. And then the second one here is really similar. Being able to pick from multiple footprints for an existing database part. This technically should work, but I ran into some bugs that haven't been resolved, and I'm not exactly sure why it's not working in some cases, but there's an issue here to track that. That should be a supported feature and just didn't work when I tried it. Couple usage limitations on the Aligni side. So the free public tier, one of the big things to point out is it's limited to 1,000 parts. So if you know that you're going to be doing designs with a lot of parts, or you have a parts library that's bigger than 1,000, you can definitely upgrade to a paid Aligni workspace, but just kind of a note on the limitation for the free tier. This last note is just a note here saying that the replicator database that gets generated by Aligni only has a single parts table. KiCad Database Libraries has a feature that will let you map different tables in a database to different libraries on the KiCad side. And so this is just a limitation on the Aligni side that it only generates a single parts table. So when you do this integration, you end up with a single library in KiCad that has all of your parts, but there's no way to separate that out into like a library for resistors and a library for capacitors and separate libraries. So that is one limitation with the system. A couple additional tips. You can check these out if you download the slides. And that's it. Thanks. Oh, sorry.
Hi. You mentioned early on in your slides that part of what you're trying to capture on the schematic is design intent.
Mm-hmm.
But it seemed like the way the talk went, you went in the direction of suggesting that what you're putting on the schematic is a super specific part number as fully defined in Aligni, which seems like that's the exact opposite. So I'm wondering if there's some portion of this where you can actually use design intent on the schematic and map that to here's the current selection we chose to fulfill these. And so later when when that goes obsolete or whatever, it's clear the parameters that need to be fulfilled for some replacement part.
Got it. Yeah, that's a great distinction you're making. So Aligni has a limitation that the way the tool is set up, it only allows a part number to be associated with a single MPN. Some other PLM tools have what they call approved manufacturer lists, which will let you map from a single part number in the system, like a generic part number, to multiple different parts from different manufacturers. The way that Aligni approaches that problem is they have, I think I mentioned it earlier, but there's that alternate parts association on every part in the system. So you're right. In this case, you would be placing a specific IPN in KiCad that's associated with a specific manufacturer part number. But then once you're in Aligni and you're going to go generate that manufacturing bill of materials, there's a way to export a report alongside your BOM that you could give to a contract manufacturer that says, this is the part that's been picked for the kind of prime part that's been picked for this assembly, but here's a list of approved alternate part numbers that can be used separately if you can't purchase the part that was intended. So it's not a perfect solution, but that's the way that Aligni has chosen to kind of implement that in their tool. Does that answer the question?
It's kind of disappointing, actually.
Yeah.
Because what Because the design intent, what happens is that over the years, because the design intent was not captured, but rather a specific part number,
Yeah.
every time the thing goes obsolete, the person doing the replacement doesn't know which specs are crucial. So we get ever escalating specs. And so the products improve by having higher and higher spec parts put on them. So,
Yes.
I mean, this one doesn't solve that particular problem. But
Yeah, I
that's
think
fine.
the way that there's two ways that the design intent gets captured. One is the description of the part gets copied over into KiCad, so you would see anything that you put in the description field would be there
Yeah.
to kind of capture the intent. And then you can always look up that part in Aligni to see what are all the parametric specs for that part that was originally spec'd.
Right, but you don't know which of those specs are crucial.
True, that's true, yeah.
Yeah, the original specs need to stay in the schematic design and somehow get managed. Everybody has the same problem.
Yeah. But I think you would have that problem anyways, because if you, let's say you pulled in a part that has, 5% tolerance and whatever else in those parameters, and you place that in a KiCad schematic, unless you make a note saying all of these parameters are important, or these two parameters are important and these ones aren't, you still kind of have that, it's still a little bit ambiguous about what was the critical parameter for that part versus what just happened to be accidentally imported as well along with it. So I think that it's a documentation issue partly that says this is the thing that was critical for this design if you really want to capture that in the schematic.
Well, I would argue it's a problem with formalizing the process the engineer uses to specify stuff.
True, yeah.
It's like required versus other specs that came along for the right.
Yeah, that's a great point.
Yes. And so, like, that's part of product lifecycle management or product documentation management. And so there's a niche there to be fulfilled yet.
Yep.
Quick question for you.
Uh-huh.
What's your thoughts on using Aligni with intelligent part numbers for the internal part number system?
Yeah, so
Pros, cons, etc.
let me go back here. They have a couple options. Go back to the part numbering scheme.
I mean, I've seen organizations flip-flop back and forth between those philosophies, and
Yeah,
big area of argument.
there's pros and cons. Aligni has a limited subset of options for part numbering schemes. So you can do completely manual. You can do auto increment where it just increments numerically. You can give it a manufacturer prefix. So you can say all the parts with a specific manufacturer have the same prefix, or a part category prefix where you say all resistors, all capacitors have the same beginning prefix.
Capacitors, types, and subtypes.
Right.
Yeah.
And I think different organizations have different requirements that will drive what your part numbers need to be, whether those are customer visible. In my experience, I have seen intelligent part number schemes kind of end up with a miscellaneous category where things that don't quite fit the other categories go to live. And I've never seen it work perfectly. I think a safer option is just kind of these generic unintelligent part number schemes, but you may have requirements, customer requirements or marketing requirements that kind of push you in a certain direction, or even manufacturing requirements where your manufacturing team might want to have, those prefixes so they know this part is supposed to be a resistor, and they can do some kind of sanity checking for things.
Great. Well, thank you so much.
Yeah.